Okay, it's going to be dealing with the last type of angle pairings that we're looking at here. And the angle pairings are based on a single line passing through or intersecting multiple lines. And the single line that intersects multiple lines is called a transversal. Okay, and so we're going to see 8 different angles formed here. Oops. Okay, when we look at the angles that are formed when a transversal intersects multiple lines, we already have some angle pairings for each kind of cluster on its own. Angles 1 and 2 are called what? Angles 1 and 2 are linear pair. They're supplementary angles. Angles 1 and 7 are vertical angles. So we have the adjacent and non-adjacent angle pairs in the single line intersecting a single line. But when we have multiple lines, okay, the angle pairings that we're going to have are based on several relationships. Okay, and it's the location of the angles. So the locations may be in the interior between the multiple lines. Okay, so this set would be considered in the interior. That's angles 2, 3, 6, and 7. Those are angles that are located in the interior of these multiple lines. And then in addition to that, you have angles that fall in the exterior. Okay, so these angles 1, 4, 5, and 8 are outside the 2 lines that are being intersected by the transversal, so those would be considered exterior angles. So there's 4 new angle pairings. Angles 1, 4, 5, and 8. Those are all considered in the exterior. Okay. I'm going to go through these 4 individual pairings here in just a second. All right. The 3 that I'm going to talk about first, the name gives away the properties of the angle pairs. Okay. In all of them, every single one of these angle pairs that I'm going to talk about here, they're all going to be non-adjacent angles. Okay, and I'll specify that. So here's the properties of alternate interior angles. Okay, alternate and interior give away the additional properties, so they are non-adjacent. Okay, they are on alternate or opposite sides of the transversal. Okay, and then finally, they're located in the interior of the 2 lines being intersected. Okay, so the angle pairs that fit this description. Okay, let's start with an angle that's in the interior. So let's start with angle 2. Okay, so what other angle is still in the interior? It's not adjacent to angle 2, but it's on the opposite side of the transversal. 6, right? Angle 3 is the other interior angle. What angle is not adjacent to it on the opposite side of the transversal and still in the interior? 7. So those would be your alternate interior angle pairs. Okay, there is no inherent relationship between these angles. Okay? They're not equal to each other necessarily. The relationships that we're going to talk about here later in the class are very specific and conditional upon the lines that are being intersected being parallel to each other. Okay, but just in general, all you can do is classify these as alternate interior angles. There's no specific relationship between their measures. All right, let's jump to alternate exterior angles. Again, the properties are identified in the name. They are non-adjacent, once again. Okay, this time, again, there are alternate or opposite sides of the transversal. Okay, and then this time the difference is that these are located, both of them, in the exterior. of the two lines that are being intersected. Okay, so if we look at our exterior angles, which are 1, 4, 5, and 8, the pairs that are alternate exterior angles, if we look at angle 1 is still in the exterior, not adjacent to it, and on the opposite side of the transversal leaves angle 5. And for angle 4, it's alternate exterior angle pair, not adjacent to it, still in the exterior, on opposite sides of the transversal, angle 8. Okay. All right, I want to jump down to the bottom one here next, simply because the name gives away its properties as well. But same side angle, same side interior angle pairs. Okay. These are, once again, non-adjacent angles. Okay, this time, though, instead of being on alternate sides, they're on the same side of the transversal. Okay, and this time, going back to the first, they are located in the interior. So if we start with our interior angle here, the first one is angle 2. We want the same side interior angle. So we want a non-adjacent angle. It's on the same side of the transversal, still in the interior. That leaves angle 3. And then our other pair, angle 6, and its same side interior angle pair, which is 7. All right, the final set of angle pairings. This is the one in which the name does not give away its properties, and that is corresponding angles. Corresponding angles, once again, non-adjacent. Okay, when you're dealing with corresponding angles, they are going to be on the same side of the transversal. But this time, they're not both located in the interior or the exterior. There's one in each. Okay, so as far as their location, one is in the interior and one is in the exterior. Okay, so for corresponding angles, let's start with angle 1. Angle 1's corresponding angle is on the same side of the transversal, but it's not adjacent to it, and it's not in the exterior, so it's the other interior angle that's not adjacent to it on the same side, which is angle 3. Okay, so angle 2's corresponding angle pair is angle 4, same side of the transversal, not adjacent to it in the exterior. Angle 5 is a corresponding angle pair with angle 7. And then finally, angle 6 is a corresponding angle pair with angle 8. Okay. So I had mentioned it before, but all these angle relationships are simply categorical. You just describe their relationship, and there's nothing that specifically relates their measures unless there's extra conditions that apply. And that extra condition is if the lines that are being intersected by the transversal are parallel. And we're going to go through that here in just a moment. But other than that, if you just need to identify specific angle pairings.